Hyperbola is also a conic section, like a circle, like a pair of straight lines, like ellipse, like parabola. And I understand that all of you have already studied the remaining conic sections. So today we focus on hyperbola. I also understand that you have got a fair idea of hyperbola also. So although our purpose is to focus on problems, I will still go through some basic concepts of hyperbola so that you get a quick revision of it, and simultaneously we will keep on solving the problems as well. Since you are preparing for engineering examination, you have to go to some advanced level questions also. But I begin with very basic questions today, where so that you develop a clear cut understanding of the various concepts of related to hyperbola. And in our next lecture, we have got 2 lectures on hyperbola. We'll take some advanced problems which are normally asked in uh, engineering competitions, and in fact they are also related to the other conic sections. Like there may be problems where you have to use your knowledge of the concepts of ellipse along with those of hyperbola and so on. So our all of you know that what is equation of hyperbola? It is x square upon a square minus y square upon b square is equal to 1. This is the most standard form of hyperbola, and as you can see here, it is the locus of a point which moves such that it's the ratio of its distance from a fixed point is always constant to its ratio from a fixed line. Okay, you can see in this particular picture that here is a hyperbola. This is a fixed point which we call focus, and this is a fixed line which we call directrix. And when we are talking of a hyperbola, one more condition is required, that this fixed ratio must always be greater than 1. And this I have already told you that the fixed point is called the focus and the fixed line is called the directrix of the hyperbola. And normally you will see that you have already seen what is the ratio called. You already know the ratio of these two things. It is called the eccentricity. Eccentricity in case of hyperbola is greater than 1. What is it in the case of ellipse? It is, in fact, it is less than 1, but it should be greater than 0. It being a ratio, it can never be negative. Eccentricity can never be negative. This you must keep in mind. So the ratio of the distance of this particular point P from the focus to its distance from the directrix has to be greater than 1. Only then it will form a hyperbola. If it is less than 1, it will form an ellipse. If it is equal to 1, it will form a parabola. So let us see the next slide also. Here we are given some distances. This is our focus. This is the point. This is the directrix. The distance from the focus to the point is given to be 45 here, and the distance from the point P on the hyperbola to the directrix given to be 30. So if we divide these two things, 45 by 30, what do you get? It is 3 by 2, 1.5, and therefore it is greater than 1. So it becomes a hyperbola. Or hyperbola always has 2 branches. So let us see some terminology connected with hyperbola. One branch is on this side, the other branch is on this side, and this is the axis of the hyperbola. You can see if we draw a line which connects this focus with this focus, it has got two foci, focus F1 and focus F2. If they are connected and a line is drawn, and if we take this particular line as x-axis and the midpoint of F1, F2, which is denoted here by C, that is taken as the center or the origin, and we draw a perpendicular line through it, this is we get y-axis. So under these considerations, when F1, F2 are joined and the line joining them is taken as x-axis, and the line perpendicular to this x-axis passing through the midpoint of F1 and F2 is a center, then you can say that this is the standard hyperbola we want to write, and the equation is x square upon a square minus y square upon b square is equal to 1, where this point is a, this point is minus a. One branch is here. If you take the reflection of this particular branch in this y-axis, you will get this branch. So if we regard this as a mirror and this is one branch of the hyperbola, you get the other branch. So we say that this branch is exactly as this, they are reflection of each other. This must be noted. And if the point C and this point where your hyperbola is intersecting the x-axis, if this point, this distance between C and this particular point is, the distance is a, then we say that the coordinates of this point are a0 and the coordinates of this point are minus a0. These are the vertices of the hyperbola. We can proceed. So this is the equation. The equation of hyperbola is x square upon a square minus y square upon b square is equal to 1. What is the equation of ellipse? So if we have plus here in between the two terms, you will get an ellipse. Okay. So you can see this axis, which is actually being represented as x-axis, is called the, what is the axis? Transversal axis of the hyperbola, and the y-axis is known as the conjugate axis of the hyperbola. I hope that is clear. And obviously these two intersect at the point 0, 0, which is the center of the hyperbola. And you can see the green lines here. We'll be discussing more about these lines later, but you can see that these lines, you can write the equations, because the first line y is equal to x is dividing, passing through origin, and it is making an angle of 45 degree with the x-axis. That means it is bisecting the first and the third quadrant. So this is justified that its equation is y is equal to x. Similarly, this line, because it is perpendicular to that, its equation must be y is equal to minus x, because if two lines are perpendicular, the product of their slopes must be equal to minus 1. So these are called the asymptotes of a hyperbola. Have you heard about it? Okay. So these two lines, we'll be discussing more about them in our next class. You see, whenever you have got any curve and any straight line, what kind of a curve it is? You can see that this curve is coming closer and closer and closer to this straight line. As you move on the line, you can see the distance is continuously decreasing. We say that this distance tends to zero. In a layman's language, we can say that this particular curve touches this particular line at infinity, or we say it becomes very close to it. Such a line is always called an asymptote. So hyperbola has got two asymptotes. There are two lines which have been represented here by green line. Let me spell it: asymptotes. Is that okay? Let's see some more properties of hyperbola. As I've already told you that coordinates of the center are 0, 0. Coordinates of the vertices are a0 and minus a0. This point is a0, this point is minus a0. They are symmetrical located with respect to the origin. जितना डिस्टेंस ओरिजिन का इस पॉइंट से है उतना ही डिस्टेंस ओरिजिन का इस पॉइंट से है, और क्योंकि वो नेगेटिव साइड पर है इसलिए उसके कोऑर्डिनेट्स माइनस ए जीरो हो जाएंगे. डिस्टेंस इज नेवर नेगेटिव. इफ समबडी आस्क्स यू व्हाट इज दिस डिस्टेंस, दिस इज a, this is also a, but minus or plus is with reference to the direction of the coordinate axis. Similarly, you can see you have a point B here and point minus B here. This B is not actually the point, it is distance between this point and this point. And here also the distance between this point and this point is B, and this B to minus B, this total is the conjugate axis. The length is determined from this place to this place. Let's see some more results. So therefore the length of the transverse axis is from this point to this point. What is this distance equal to? 2a. Similarly, what is this distance equal to? 2b. So that's what we call the conjugate axis. Length of the conjugate axis is 2b. Length of the transverse axis is 2a. You had something similar in ellipse, because you need to revise ellipse also, and you have to keep in mind all the results. When you are going to solve some objective type problems, the most important thing is that you should know all the results very clearly, and you should know all the concepts very clearly. When we come to some more advanced problems in objective type, we'll see that how graphs can help you in solving so many problems. But graphs are sometimes difficult to learn, but once you learn them, the problem solving becomes very, very easy. What was the case of ellipse? This was the major axis, this was the minor axis. Why we call it major axis? Because this length is greater. Is that okay? Okay. We see some more results on hyperbola. Eccentricity of the hyperbola, which is denoted by E, is given by this. It is a square plus b square divided by a square and the square root of. You can write it in different forms, as we see in the next slide. This term can also be written like this: 1 plus b square upon a square under root. So E square is this or this. So these results are very important. We'll be using them. The relation between A, B and E, what it means, whenever you are given any two of these quantities, you can find the third one. Let us see. We have a adjuster. Suppose we take x square upon 16 minus y square upon 24 equal to 1. This is a hyperbola. What is the value of a square? 16. B square equal to 24. So a is 4. B is square root 24. Actually, it gives you two values. A can be plus minus 4. B can be either plus root 24 or, so it is giving you both the points. Now you know that relation. What was that? A square. You can use it like this. E square is equal to 1 plus B square over A square. You can see in this case, can we find the value of E? In fact, you can see that we need not find these values. These values are sufficient in order to find out the value of it. It is 1 plus 24 divided by 16. It is 1 plus how much? 3 by 2. That means it is 5 by 2. So E is root 5 by 2. I could have written plus minus, but since it is a ratio, it cannot be negative. So the value of E is root 5 by 2. We'll see a number of problems where two of the quantities are given to you and you have to find the third one. And we'll just see that so many things you can find out using these. A and E are the most crucial things that you need to know in a hyperbola. If you know A and E, you can find out B, and you can find out in fact everything. Like here you can see the coordinates of the foci are A is 0 and minus A is 0. This distance is total distance. Because this is the origin, we need to calculate distance from C to focus F1, and this distance comes out to be AE. This you should know, because the purpose here is not to get into derivations. If you have already done it, very fine. If you have not done, just see. So AE0, and because the two foci are symmetrically located, one on the right side of the y-axis, the other on the left side. So the other one will be AE minus. Is that okay? And you can see these straight lines. These are the directrices. Let us see more results on this. Now these are the equations of the two directrices. One is x is equal to A by E. The other one is x is equal to minus A by E. Is that okay? I'm again not going into derivations of these things, but this clearly tells me that distance of this point and this point. What is that? Distance from the center of the hyperbola to a directrix is A by E. When I say that a line has equation x is equal to 5, what it means? What it means that if you take your coordinate axis, x-axis, y-axis, which are the points for which you have x is equal to 5? This is 1, this is 2, this is 3, this is 4, this is 5. If I take a point here, what will be the x coordinate? 5. What are the coordinates of this particular point? 5, 0. Suppose I take this point, its coordinates are 5, 1, if this is 1, suppose I mark a point 10 here and take this point 5, 10. So what is common between all these points? Their x coordinate is 5. And what we have written? X is equal to 5. That means the equation of this line is x equal to 5. So whenever I say that the equation of line is x equal to 5, that means it passes through the point 50 and it is parallel to. Similarly, x equal to minus 5. Now you can draw any line like this. Where will x equal to 6 be? At a distance 6 from this. X is equal to 20 will be at a distance 20 from the origin on the right hand side of the y-axis. Similarly, x to minus 20 will be somewhere. So now coming to directrices, x is equal to a by e. When I say that the directrix is x is equal to a by e, it means that from the origin you have to go a distance a by e on the right hand side. So x is equal to a by e is one directrix. X is equal to, okay. Then what about AE? AE 0 is focus and another focus is minus AE 0. Can you tell me if this is A by E, where will A into E be? On right of it or left of it? Right. Why? Because E is a number greater than 1. When you have divided A by E, it has become smaller. This distance is less than A. So A is somewhere here. And A is still farther. Why? This is A. You are multiplying it by a number greater than A. And what was this? Focus. This was the center. Something like this is going to happen. This is A0. This is A E0. This is x is equal to A by E. This is the relationship between the directrix x equal to A by E, the vertex of the hyperbola, and the focus. So this will always lie between this and this. So similar thing will happen here also. This point will be minus A0. This point will be minus AE0, and somewhere here was your y-axis, and this is the line x is equal to minus A by E. I have already written. So this is x-axis. That means given A, I have been able to retrace the hyperbola. If you know that A is this, and of course A, B and E, at least two things must be known. If you are also given B, we will see that we will be able to draw the hyperbola exactly. Because still there is one problem. I do not know my hyperbola is here or here. How wide is the hyperbola is still not known to me. So I do need something more in order to see how wide is my hyperbola. Otherwise, everything has been fixed. Its center is known. Let us see. And that is provided by the latest rectum of the hyperbola. You know it in the case of parabola as well as ellipse. Let us see. This we have already seen. That what is the equation of transverse axis? Because it is representing x-axis. What is the equation of y is equal to 0. Every point on the x-axis has y coordinate 0. Similarly, every point on the, so therefore we have the equation of transverse axis as y equal to 0 and that of conjugate axis as x equal to 0. So let us see, before coming to latest rectum, let us see a few concepts. I'll come back to tracing of the hyperbola again. Just if this is the focus, suppose this is your hyperbola. If this is the focus, if I draw any line passing through this is called a double ordinate, passing through focus. Otherwise, if I draw this line, this is also a double ordinate. But this double ordinate is not passing through the focus. So if this is focus, let's call it F1. So this is a double ordinate passing through focus. This is called the latest. So as we see in the definition here, a double ordinate passing through focus is called latest sectum. But we can define it in some other way also, as we see in the next slide. It's a focal chord parallel to directrix. What it means? Focal chord means, what is a chord? In case of, no, what is a chord? It is a line joining, a line segment joining any 2 points. Suppose we are talking of a circle. You take 2 points on a circle and join them, you get a chord. As suppose this is a circle, I take a point here, I take a point here, this is a chord. Whatever curve you take, suppose ellipse, join. But some chords are always given special names. Like in circle, a chord passing through center is called, what is good about this? It is the largest chord you can draw in a circle. Similarly, when you are talking of a hyperbola, any chord passing through the focus is called focal chord. So there can be how many focal chords? Infinite. Anything passing through this one, anything. But only one of them will be perpendicular to x-axis or parallel to the directrix. You can see that y-axis and directrix are parallel and both of them are perpendicular to x-axis. So either I say a focal chord parallel to directrix or parallel to y-axis or perpendicular to the transverse axis or x. All the things are the same, exactly. Oh, I have intentionally tilted this picture. Just see the next slide, the previous slide. In that slide, you can see that the same picture was there. What was the relative position? These lines are parallel and they are perpendicular to this line. That means transverse axis and conjugate axis are perpendicular. Directrix is parallel to the conjugate axis. It is perpendicular to the transverse axis. But this position does not change in the next slide. Even if I have drawn it a bit oblique, what it means is, just see the next slide. If somebody on a piece of paper draws like this, he takes this x-axis and this y-axis, nobody stops you from doing this. But then the relative positions of these things should not change. You can see here, this focal chord is still parallel to this and it is still perpendicular to this. And therefore its length also. If I draw a few things and rotate the line, the distance between various points on the plane does not change. So therefore it hardly matters Because in advanced classes, you will sometime be reading if axes are rotated, what happens. These things you can see. Uh, we must understand very clearly that why we are studying conic sections. Although this is not directly connected with problem solving, but whatever you are studying in mathematics, in any branch of mathematics, complex numbers, calculus, algebra, coordinate geometry, there is nothing which will not be used practically in real life. All your planets are moving in elliptical orbits. When a planet is being attracted by a sun under some gravitational force, it revolves in the form of an ellipse. So there, like you have seen somebody something moving in a circle many times. A wheel rotates, okay, and it also translates. That's a separate issue. But suppose there is a car standing, somebody lifted through a jack, and the wheel is rotated. There will be a circular motion. And you always want to know that if our planet is here today, what time will it reach a particular point? That can be calculated. How do you calculate the position of a point? What is the distance traveled and what is the time taken? You can, speed, etc. You can calculate like that. So therefore, we must know what is the distance, because this distance is not going to be the straight line distance. If you travel from one point to another point through straight line or through a curve, the distances are going to be different. So if something is moving on a circle or an elliptical path, definitely the distance traveled has to be different, because we have to deal with real time things where these occur. क्या होता अगर प्लैनेट्स पैराबोलिक पाथ में मूव करते या हाइपरबोलिक पाथ में मूव करते? तो अगर हमारी पोजीशन ये है तो वो शायद हमें यहां दिखते, because we have an area beyond which we cannot see. There's some area beyond which we cannot see. So suppose this planet is visible to us from this place to this place, then from this place to this place. तो हमें planet एक बार यहाँ दिखता, एक बार यहाँ दिखता, and where will it go? It will go to infinity, never to return. So it's good that the Earth is moving in a elliptical path so that we are surviving. Otherwise, at one point of time, we'll be here, and maybe we are lost into some other galaxy or somewhere else, to some other position of universe, never to come back. Sometimes you see some comets falling. That means they have lost their path in a way. Due to certain things, they have gone out of their orbit and they are having a free fall. Whenever something falls freely, for example, this is going to form a parabolic path. You can see I just threw it, it will go up and it will come down. And this will always be parabolic path. You can see when a cricketer throws a ball, it is in parabolic. Even if you shoot from a gun straight, it will go on a straight line, but still due to gravitation, it will fall down. So sometimes it will come into parabolic path. So whenever something falls, so therefore we must know if we are throwing up, of course, when you are throwing, you are applying some force. When will its speed become zero? From that point onwards, it will start falling down. So all these are engineering applications. For circular motion, so you will find everywhere. See an aeroplane, उसके अंदर कितने ही ऐसे पुर्जे होंगे जो गोल घूम रहे हैं. So many things. Wheels, everything is around wheels. If you open a machine, there will be so many wheels inside, you know. Or one wheel is moving another wheel, they are connected by a belt and so on. So all the study of conic sections therefore becomes very, very important. It has not come out of the blue. Most of the mathematics has been created because it was needed. And you will wonder that most of the mathematics has been created by non-mathematicians. At least the ideas have come from there on. If somebody is a biologist, he wants a problem, he has a problem, he wants a solution, he can model it mathematically and then solve. Okay, we continue with what we are doing. So I was just trying to tell you that at certain stages, we may be needing that our axes are rotated or they are not even at right angles. I cannot discuss that right now, but fortunately we'll discuss some of that. Please let us see. So the length is important. For you, this length is important. 2b square upon a. For parabola also, you had the length of the lateral rectum. For parabola also, you know what is the length. Similarly, you should know for ellipse also. And for hyperbola, it is 2b square upon. Okay. Let us see some more property. In fact, I have not given any choices for this question because it is hinting towards a certain property. The question is, which conic section does the equation this represent? It depends on values of a and b. Suppose I take a is equal to, let's take an example. What is the equation I have written? Ax square minus by square equal to 1. Suppose I give it value, a is 3 and b is minus 5. What it becomes? X square plus 3x square plus 5y square. What is this? Is it a circle? Sure? It's not a circle. For a circle, the coefficient of x square and y square should be equal. They are not equal here. It is an ellipse. It's an ellipse. We'll see why. So I wanted you to understand it well. Given any equation in x and y in second degree, you understand what is the second degree equation? What is the first degree equation? An equation which contains at the most one power of x and at the most one power of y is called a linear equation or equation of degree 1 in two variables x and y. So this is a second degree equation. In this, x is having power 2, y is having power 2. There are two terms and both of them are second degree. You can have other terms. I'll come to that. So this is an ellipse. Suppose I give some other value. A is equal to minus 3. B is equal to 5, say. What do you get? A is minus 3. So it becomes minus. It gives you 3x square plus 5y square. What is this equation? Do you know some points for which this will come out to be minus 1? It will not, because this is a perfect square. It cannot be negative. This is a perfect square. It cannot be negative. So 3x square plus 5y square can never be equal to minus 1. What it means? No point on the plane can satisfy this. So it does not represent any point on the you cannot have real x and y for which this happens. This is what was meant by this question. You should clearly see. Now my question is, for different values of a and b, what is this term? Let me be specific. For what values of a and b will it be a hyperbola? You know some condition? Okay, if you want, you cannot recall it, Then let us see the next slide. This is the algorithm. So if the square terms have opposite sign, it's a hyperbola. If they have the same sign, again we are confused. It can be an ellipse, it can be a circle. So what is the next test? If they are equal, it's circle, otherwise it is an ellipse. So let us see. I have written a few questions for you. You yourself see whether they are what particular conic section are they representing. The equation here is 8x square minus 8y square. It is representing a hyperbola. If you just click, you will get that. Can you open it as a slideshow? Because now if you click, you will get the answer. So answer is C. Answer is C. Why? Because coefficient of x square is 8 and coefficient of y square is minus 8. They don't have to be equal in magnitude. 8 or minus 4 hota to bhi ye hyperbola. The only condition is they should be different in sign. See the next slide. 8x square plus 8y square. Here the coefficient of x square is exactly equal to coefficient of y square and they are both having the same sign, circle. और अगर ये दोनों नेगेटिव होते, दोनों नेगेटिव होते तब भी साइन सेम होता, तब भी सर्कल बनता. For example, if you have, let's see this. Minus x square minus y square minus plus 1 equal to 0. You can write it as x square plus y square minus 1 equal to 0. It is a circle. But there may be cases, for example, had it been this, so this will not be possible. But if you are given that it is representing a conic section and you are asked which particular conic section it is, that means this situation will not occur. X square plus y square equal to minus 1. No point. This equation is not satisfied by any point on the xy plane. So let's see one more question. Oh, I want the answer to come later. I mean, let them try. Anyhow, no issues. 8x square plus 16y square. Both x square coefficient and y square coefficient, they are positive, same sign, and they are different. So it has to be an ellipse. You can convert into the standard form of x square upon a square plus y square upon b square equal to 1 sum. So these kind of problems you can tackle now. There are certain advanced conditions also with the help of which you can check up which particular conic section is represented by a general equation of second degree or a given equation of second degree. But I think for your purpose, for your class, this criteria serves the purpose. Okay. Let's go a bit further. This again, similarly you can do this. Oh, why? Because only one second degree term is there. Y square is there, but x square is missing. So it has to be a parabola. Now we can find out everything about it. Let's see the next. Again, this is a hyperbola. This is a hyperbola because the coefficient of x square and coefficient of y square have opposite signs. I think it is well understood now. You can try some more questions from whichever source you obtain questions. Okay, let us see the length of transverse axis. Because it is given x square, what is the equation? Can you read it for me? X square upon 1 upon 9. So what is a square? And what is b square? And what is the length of transverse axis? 2a. So we are interested only in this. So in an objective type question, you must not try to solve questions. Just first see what is asked. You have been asked that what is the length of the transverse axis? That is 2a. So we only need to know a. So from here we know that a square is 1. So a has to be either plus 1 or minus 1. But we take a as positive because the other adds length. So therefore 2a is 2. So answer is perhaps B. Okay. Let us see. The eccentricity of the hyperbola is given. Now we know all the concepts. Therefore, I have given you some problems based on those concepts. So let us try to solve this question. For your convenience, I have also given what results can be used. We know that length of latus rectum is equal to 2b square upon a, and the relationship between a, b and e is given. Now let us see what I do. Latus rectum is 2b square upon a, and you are given the latus rectum is 8. This is given to me. Then I have this relationship which connects A, B, and E, and eccentricity is given to be 3 by root 5. So it is 9 by 5. Given these two things, what do we have to find? We have to find the equation of the hyperbola. Equation of the hyperbola is known to us if we know A and if we know B. Only two things are required. So can we find A and B from here? The first result gives B square is equal to 4A. Is that okay? I shift A to that side, divide by 2, B square becomes 4A. And eccentricity was given. I have already squared it up. So this is the second equation I am getting. So let me substitute the value of B square. B square is given to be 4A divided by A square is equal to 9 by 5. That means 4 upon A, this A cancels out with this, is equal to 9 by 5 minus 1. That means it is 4 by 5. Can I reduce that A is, A is 4? Because what you are having is now 4 by A is 4 by 5. This means A is 5. And what is B? B square is 4 into 5. 4A hai na? It is 20. A square is 25. X square upon 25 minus y square upon 20 equal to 1. Do we have the choice? See the question on the slide. Is there a choice like this? The second choice. One more thing. When you are attempting an objective type question, suppose you get A is equal to 5. That means you must have x square upon 25, x square upon 25 as one term. So if there is only one choice with this, then you need not do anything else. Why should we? Because the purpose here is solving in the minimum possible time. You will be short of time always in a competitive examination. तो इसमें हमें इससे ज्यादा कुछ करने की जरूरत नहीं थी. B की वैल्यू निकालने की जरूरत नहीं थी, क्योंकि जैसे ही हमने ये निकाल लिया और कोई चॉइस ही नहीं है. हाँ, अगर इसी में none of these choice हो, then it would be a problem. So please be careful in a competitive examination. If you are getting A is 5, that means A square has to be 25. There must be a term containing x square 25. You should not immediately take that, but see if there is no choice with none of these types, because it's possible that even that is not true. Then you have to find the value of B also, or if there are two problems, two choices in which both of which have x square upon 25, then you have to positively find out B. So you have to find techniques for solving. For example, I tell you, though we are discussing hyperbola, the scope is not restricted to that. Suppose you are given an ellipse. Equation is x square upon, say, 16 plus y square upon 9 equal to 1. What is the major axis? A square is 16, so A is 4. So this is 8. So the coordinates of this are 4 है? No. Yes. 40 and minus 40. What are the coordinates of this? Let me write 9. That will be better. So 0, 3. Suppose you are given a question. The line x is equal to 5 meets this in, and choices are 1 point, 2 point, no point. So how do you do that? Normally what we do is, if an equation is given y in terms of x, we substitute the value of y and solve it for x. But since it is x equal to 5, just imagine the graph of this. This point is 40. X equal to 5 cannot intersect it. I mean, sometimes the graphs will help you. If you are, somebody asks you what is the intersection of y is equal to 5 and this ellipse, no intersection. If somebody asks you what is the intersection of y is equal to sin x and y is equal to 3, no intersection, because sin x cannot be more than 1. Sin x cannot be less than -1. So intersection of sin with this, it will not intersect. So sometimes the picture you have in your mind of the graph of a particular function, that will play a role. You will not have to touch your pen in order to solve a given objective problem. And if some objective type problem is involving you too much, make sure it is not to be solved there. Just leave it. If you are spending 20 minutes on a problem, there are two possibilities. Either you have taken a wrong path, or the examiner has put this problem just to take your time away. Okay, you have not clicked the right thing. No objective question can be very involving so far as calculations are concerned. Okay, let's see some more problems. Oh, this is something interesting. The equation given is x square upon 12 minus p plus minus y square upon 8 minus p equal to 1. For what value of p will it represent a hyperbola? That is the question. Suppose that means you say 13. You want 12 minus p to be greater than 0. Okay. 12 minus p, somebody is saying that it should be greater than 0. That means p should be less than 12. What about this 8 minus p? It should be, you want this negative sign to be retained, because the equation you want is x square upon a square minus y square upon b square equal to 1. So you want 8 minus p also to be positive. So p, 8 should be greater than p, or I can write p should be less than 8. So you can combine these two things. P should be what it means. 8 minus p, you want to be greater than 0. That means 8 is greater than p. P coming out to be less than 8. And p also less than 12. So that means, you mean if you take any value less than 8, will that do? Suppose I take p to be 5. What this equation becomes? X square upon 7 minus equal to 1. So this is giving you a hyperbola, p less than 8. Okay. What if I take something greater than 12? Greater than 12. This, suppose I take p as 13. What will happen? Suppose I take P as 13. So x square upon minus 1 minus y square upon 8 minus 13 equal to 1. This becomes minus x square upon 1 plus y square upon 5 equal to 1. Is it a hyperbola? This is also a hyperbola. This is called the conjugate hyperbola, to which we'll come later on. If you have a hyperbola like this, the conjugate hyperbola is like this. The conjugate axis of the first becomes the transverse axis of the conjugate hyperbola and vice versa. So this way you can find out. The choice here, I don't think correct. You solve this problem and try to find out the values of P for which this is. So at least for P less than 8, it's coming out to be true. Let's see the next problem. We have to check whether the second answer C is right or not. Can we see the question again? Just 12 minus P and 8 minus P. Is this C choice correct? Let's see. Suppose I take a point which lies between 8 and 12. Suppose 10. What does the question become? X square upon 12 minus 10 minus y square upon 8 minus 10 equal to 1. This makes it x square is equal to 2 plus y square upon 2. What is this? This is a circle. So that means the choice, this answer is not correct. There is a typo. So answer is P less than 8. B should be the correct answer. You can please verify. P greater than 8 के लिए क्या होगा? Let us check all the possibilities. If there is a confusion, let us check all the possibilities. This is not serving the purpose. This has done it. Let us also check. Is there any chance of, normally the questions in which 2 correct answers are there are not asked. But since there is a mistake in this answer, let us check the first criteria also. P greater than 8 में क्या होगा? P greater than थोड़ा डाइसी है. P अगर greater than 8 है तो P तो 12 से भी बड़ा हो सकता है. तो अगर हम सिर्फ 8 और 12 के बीच में रहना चाहते हैं तो यही चॉइस हो गई. ठीक है, ये चॉइस तभी मीनिंगफुल है जब आप 12 से बड़ा लें. 12 से बड़े नंबर के केस में एक डिफरेंट आ रहा था तो हाइपरबोला नहीं रह रहा था, क्योंकि उस केस में क्या हो रहा है, जब 12 से बड़ा हो जाएगा तो ये भी नेगेटिव हो जाएगा. अच्छा, उसमें हाइपरबोला कंजुगेट हाइपरबोला बन रहा था. सो देयर सीम्स टू बी a problem. So P less than 8 is true and P greater than 8 at least for some choices is giving. In general it gives it or not, we have to check. Right? If we take any number greater than 8, what happens? This will always be negative and this will always be positive. So this is positive, so it is always be giving you hyperbola. That means 2 choices are correct here. Have you understood this? Let me repeat this question because the choice I had written there is not correct. Let us carefully examine it so that there is no confusion. X square divided by, read it for me, 12 minus P. Okay. Whenever you choose P greater than 8, 8 minus P is negative, so this term becomes positive. And when P is greater than 8, this can be positive, this can be negative. This can be positive, this can be negative. If this is positive, suppose P is as big as 13, then this sign becomes positive and this sign negative. So it gives you a conjugate parabola. So what then? But if you take something lying between 8 and 12, what happens? This becomes, this is positive, therefore this minus sign is retained and this positive sign is retained. You are getting a hyperbola. So you can see the conditions. The question should be reframed. There are some discrepancies. But the main purpose here is that you have understood what kind of possibilities are there. It was not a well framed question. Let's see another question. But we have understood a lot from this. Sometimes from mistakes we learn a lot. Let's see the next question. This should be simple. Eccentricity of hyperbola is to be obtained given its equation. 3x square minus 4y square is equal to minus 12. When I divide by minus 12, what I get is x square minus 12 plus 4y square upon minus 12 equal to 1. So it becomes x square upon minus 4 plus y square upon 3 equal to 1. Just let us see, before solving this question, something about the conjugate hyperbola in the next. Please show the next slide. Minus x square upon a square plus y square upon b square equal to 1 is the conjugate hyperbola for the hyperbola x square upon a square minus y square upon b square. What I'm saying is x square upon a square minus y square upon b, if this is the given hyperbola, its conjugate is minus x square upon a square plus y square upon b square equal to 1. And you see the eccentricity. Can you find some difference? The eccentricity of this is 1. The eccentricity of this was 1 plus. That is the difference you get. And whatever is known to you, for example, A0 is the focus. Here the focus will lie on y-axis, conjugate hyperbola. We'll discuss it in detail in the next class. If you interchange A and B and shift the coordinates, I mean A0 to be replaced by 0B. So you will get all the details about a conjugate hyperbola. We'll do it a bit later. But for this question, we have to use this formula. E square is equal to 1 plus a square upon b square. So this is very simple, I suppose. I need not solve it. You do it because this minus has to be written here. So a square is known to us, b square is known to us, and we can proceed. Let us see this. The two foci are given. That one is 4, 5 perhaps, or minus 4 है. This is 6, 5. It says the hyperbola has these two as a foci. One focus is at -4, 5. The other focus is at 6, 5. And eccentricity is given to be 5/4. Then its equation. You have to find out the equation. Let us, before doing this question, see something. If I take this as x-axis, this as y-axis, let us try to plot the two foci. Where is the point -4, 5? Somewhere here at the height. If this point distance is -4 and this is 5, -4, 5, the point will be there. Let me call it F2. The other point is 6, 5. 6. This point is 6, 5. This is the other focus, F2. So this is the line joining the focus. If somebody tells you that a point is here, a point is here, and these are the two foci, that means the center is somewhere here. Both the foci, focus F1 and focus F2, are at the same distance from the center of the hyperbola. In this case, the center is not origin. So its equation is not going to be x square upon a square minus y square upon b square. In fact, center, where will be the center? Midpoint of the two. What is the midpoint? 6 and -4/2. Midpoint is 6 plus -4/2. This is 1. So this is the x value of the x coordinate of the center of the hyperbola. What is the y coordinate? It is 5 plus 5/2. This is the value y. That means the coordinate, y coordinate of the center of the hyperbola. Where is the point 1,5? Somewhere here. But still you can see that all the 3 points, F1, F2, and the center, they are lying on a line which is parallel to x-axis. अगर ये लाइन पैरेलल टू एक्सिस नहीं होती तो इसमें इक्वेशंस की प्रॉब्लम आ जाती. अगर ओब्लिक एक्सिस हो तो कुछ और देखना पड़ेगा. बट स्टिल center is not 0, 0, but it is somewhere here. Okay. Now let us read the question again. It says, what is the equation? So first of all, we should find out the midpoint of the two foci. That will be the center of the hyperbola, which we have obtained as 1 and 5. That means the equation will be of the type x minus 1 whole square upon something minus y upon y minus 5 square upon something. That we have to calculate. That means we have to yet to find a and b. अगर हाइपरबोला की जो एक्सिस है वो हमें मालूम हो और वो पैरेलल टू एक्स एक्सिस हो तो उसकी इक्वेशन कैसे होती है? x माइनस h होल स्क्वायर अपॉन a स्क्वायर माइनस y माइनस k होल स्क्वायर अपॉन b स्क्वायर इक्वल टू 1. So we have to find a and b. And how do you find a and b? Using these equation. What is the distance between the two foci? एक की कोऑर्डिनेट्स AE0 होते हैं, दूसरे के -AE0. तो अगर 0 से AE तक और 0 से -AE तक जाए तो हम AE डिस्टेंस 2 बार ट्रेवल कर रहे हैं. इसका टोटल डिस्टेंस कितना हो गया? 2AE. और साथ में हमें इक्वेशन है b स्क्वायर इक्वल टू a स्क्वायर e स्क्वायर माइनस 1. Now eccentricity is given to us. Let me copy these results here. B square की हमें वैल्यू जो स्टैंडर्ड रिजल्ट है उसमें E गिवन है क्वेश्चन के अंदर 5/4 और दूसरा 2A हमने कैलकुलेट कर लिया है कि ये 10 है। क्यों 10 है? क्योंकि दोनों फोकस दोनों फोकाई थे उनके बीच में डिस्टेंस 10 था। एक 5 इधर था, 5 एक्सिस के, एक 5 सेंटर से। कोऑर्डिनेट्स क्या गिवन थे? 6 और 5 और -4 और 5। इसके बीच में डिस्टेंस हम डिस्टेंस फॉर्मूला से भी निकाल सकते हैं, पर हमें श्योरली मालूम है कि ये यहां से 4 डिस्टेंस इधर है और ये 6 स्टेप्स इधर है। हमारा एक फोकस F1 एक्स एक्सिस यानी ओरिजिन से एक्स एक्सिस और वाई एक्सिस का जो इंटरसेक्शन है ओरिजिन उससे 6 स्टेप्स राइट पर है और एक फोकस F2 4 स्टेप्स लेफ्ट पे है, तो टोटल डिस्टेंस 10 हो गया। अब इसके लिए हमें कैलकुलेशन करने की जरूरत नहीं होनी चाहिए। सो देयरफॉर वी नो दैट 2A is 10। अब इस इंफॉर्मेशन को यूज करके अगर हम A और B निकाल लें तो हमारी इक्वेशन निकल जाएगी। I am just repeating. We have already written our equation of hyperbola at least till this stage. I just have to write what comes here and what comes here. That means A square and B square. So let us solve. 2AE is 10, means 2 into A into 5/4 is 10. That means A is 40 divided by 10, 4. When A is known to me, I definitely know A square, which is 16. Are the calculations okay? B square is A square, E square minus 1. A square is 16. E square is 25 by 16 minus 1. So it becomes 16 into 25 minus 16 divided by 16. That means 9. So we have obtained that B square is 9 and A square is 16. So I should write 16 here and 9 here. So this was a case when the axis of the hyperbola was not x-axis, but it was parallel. But calculations remain the same. It is just like that I draw it on a paper and shift it upwards. For example, if this is my axis and everything is drawn here, I just shift it here. So nothing is going to change except the coordinates. Distances will remain the same. So instead of x square, we have x minus 1 square. Instead of y square, we have y minus 5 square because of the center of the. Now suppose you are given center of a hyperbola is say -2, 3. A is given to you as 5 and B as 7. Can you write the equation now? It is x minus -2 now. Because as I told you, if the center is HK, equation is x minus h whole square upon something and y minus k square upon b square. So this divided by a square is 25 and is 49 equal to 1, and you can write x plus y minus 3. So it becomes x plus 2 whole square upon 25 minus y minus 3 square upon 49 equal to 1. This we get as the equation. And if you expand these expressions, you will see that it will again be a second degree equation in two variables x and y. Will you get something like x square? X square plus 4 plus 4x. Similarly, from here you will get. That's okay. So I hope every student can expand this and see. But if in the examination, even if it is a subjective question, you have to stop here. Okay. But this was an objective type question, and there were certain choices. Let us see which choice is correct. Perhaps A is written. It's not clear. So we have seen a number of problems through which you can strengthen your concepts. A, B, what do they represent, how important they are, and E, eccentricity, the focus, the directrix, equation of the directrix, length of the transverse axis, its equation, length of the conjugate axis, its equation, and so on. So these were some basic things about hyperbola. Let's proceed further. Coming to the equation of tangent. Now, before we come to equation of tangent, let us see, given a line and given a hyperbola, in how many points can they intersect? Such problems you have seen in case of parabola, ellipse, circle, everything. And the general result is, given any conic section, a straight line can intersect it at the most in 2 points. At the most in 2 points means either 2 points or 1 point or no point at all. For example, if I draw is not finite. You should keep it in mind. Ellipse is enclosed in a particular region. It's a closed curve. But parabola and hyperbola are not. So though it may seem, because line, when I talk of a line means an infinite line, not a line segment. When will it touch 1 point only? When it is a tangent. For example, at this point, I draw this line, or at this point, I draw this line. Similarly is the case with ellipse, circle, and every conic section. A line can intersect a conic section in at most 2 points, either no point or 1 point. When it meets it in 1 point, it becomes a tangent. Let us see in the case of hyperbola. This is a branch of the hyperbola. This is another. So we are talking of one branch. If a line like this is taken, it will meet in 2 points. I can draw a tangent here. It will be intersecting just in 1 point, or it may not intersect. If I take a line parallel to the directrix, but within this region, mind it. If this point is say 3, 0, this is definitely going to be minus 3, 0. If in the examination you are just given this, there is a hyperbola with vertices at 3, 0 and minus 3, 0. In how many points will the line x equal to 5 intersect? You do not need any other information. Where is x equal to 5? Here. Now you cannot draw any line passing to this point which will not intersect the hyperbola in 2 points, except this line. I'm talking of this branch. But what is this line? X equal to 5. It's a line parallel to, so it has to intersect in 2 points. So no calculations are required. No other information is required. Only we know that the focus, one of the focus is at 3, 0, the other focus at minus 3, 0, and it is a hyperbola. But what about the lines parallel to x-axis? If we are considering the hyperbola as a whole, then it is intersecting in 2 points. Otherwise, normally we talk of one branch, so it intersects in only one. So we can talk of tangent to a hyperbola now. But when we talk of tangent to a hyperbola, we should be given two things. The hyperbola must be known to us and a point on the hyperbola. So this is important. On the hyperbola. If the point does not lie on the hyperbola, situation is very different. Suppose I redraw a figure. Suppose this is your hyperbola. Let me not draw the axis. Suppose this is the hyperbola. If the point does not lie on hyperbola, then talking of the tangent is a bit confusing, because every line passing through this will not be the tangent. You have to look for one line which touches it. That's an entirely different thing. So in this question, we are talking of a point which lies on the hyperbola. That means one precondition is the coordinates this point must satisfy the equation of the hyperbola. How do you check whether a given line, a given point lies on the hyperbola or not? The coordinates of, that means the value of x and the value of y, when you substitute in the hyperbola, it must be satisfied. If on the right hand side you have 1, it should come out to be 1. The left hand side, if it is 10, it should come out to be 10. So this precondition must be kept in mind always. So if x1, y1 is a point on the hyperbola, then we can have the equation. And it is easy to find out. You have two terms, x square and y square. X square contains two x's, x into x. So one of the x's to be replaced by x1. Y square again is y into y. One of them has to be replaced by y1. And can you realize that this was a technique in ellipse also? There, the ellipse was x square upon a square plus y square upon b square equal to 1. And the equation was x into x1. Wherever x square is occurring, we are replacing it by x1. Whereas wherever y square occurs, we replace it by y into y1. What about parabola? Because you have to, the case of parabola is typical. Suppose 6x is there. So y you will replace by y and y1, and this as that means what is the basic criteria? If there is y square, write it as y into y, replace 1y by y1. If there is x square, write as x into x, replace 1x by x1. And if there is something like 2x, write it as x plus x and replace 1x by x1. 2y, y plus y, and this applies to every conic section, to cone, to ellipse, to a parabola, to an ellipse, to a hyperbola. So equation is okay. Let's see if we have some problems on this, but before that, we should also find out the equation of normal. Normal, you understand? A normal at a point is perpendicular to the tangent at that point. If this is any curve, and this is the point, I draw a tangent. This is a normal. This is true for every curve. Suppose sin x. This point, you draw a tangent, perpendicular, you get a normal. For a circle, normal always passes through the center. This may not be the case in other curves. Not every general. So the equation here also you can see the equation becomes a square upon x1, b square upon y1. Actually, this is using the equation of hyperbola. So we cannot generalize this result as we generalize that result in case of circle or parabola or ellipse. So this result you know that, to learn it, a square x, let me write it here, so that you can see even if you proceed further. A square x upon x1 minus b square y upon y1 is equal to a square plus b square. This is equation of normal. Let's see some more results. You are familiar with the parametric form? Actually, there are a number of systems through which we can locate the position of point. When we are writing the equation of a curve in terms of x and y, we call them Cartesian coordinates. What happens is, you take any value of x, you get a corresponding value of y. How do you draw the graph of sin x? Take one value of x, write the corresponding value of y, calculate it and plot it. Take another value, plot it. Go on taking different values of x, then find the corresponding values of y. When you get the points, this is a rough method of doing it. Although we have to do many advanced calculations in order to trace curves, but this is a general process. Given x, we can find out y. But sometimes what happens is, we can also have equations like this: a cos theta, y is sin theta. Here it appears that x and y are not related to each other, but they are connected by one parameter. This theta is called the parameter. Now what happens? If you put theta is equal to 0, you get a value of x, which is a because cos 0 is 1 and y 0. So you can see every value of theta is giving you a point on your xy plane. So with the help of parametric equations also, we can plot our curves in the xy plane. And you can see very easily that this equation is nothing but that of a circle which has center at 0, 0 and whose radius is a. You keep on finding out different values. Put theta is equal to 0, you get this point. Put theta is equal to pi by 2, you get this point. This corresponds to theta is equal to pi by 2. This corresponds to theta is equal to 0. Theta is equal to pi. What will this become? X is equal to a cos pi. Y becomes a sin pi. Cos pi is minus 1 and this is 0. Similarly, so you pick up any point in between the whole of this curve. Theta, you can take theta is equal to 1 degree, half degree, whatever you like. It's a different thing that you know values only for standard values of theta like 0, 30, 45, 60. But there are trigonometric tables are available, or through a scientific calculator you can find value even from 43 degrees and plot all the points and join them. You get a circle. This is called the parametric equation, basically because there is a parameter which helps in defining both x and y and in calculating the coordinates of a particular point. Similarly, we can have a parametric equation of hyperbola. That is what is being shown here. X is equal to a secant theta, y is equal to b tan theta. You can see that if you substitute, we'll get 1. It satisfies? Can you check? Simple thing is that if I take x is equal to a secant theta and y as b tan theta, then x square upon a square minus y square upon b square is 1. This is satisfied. If I substitute x as a secant theta, it will become a secant square theta minus b square tan square theta upon b square equal to 1. So this becomes secant square theta minus tangent square theta equal to 1. You can see that both sides are equal, and therefore we say that whatever may be the value of theta, this point xy, which depends on theta, will always lie on the hyperbola. Is that true? Is that okay? You can try, pick up any hyperbola. For example, let me take one hyperbola. X square upon say 16 what is a square? 4. What is b square? 9. So I have to define now x as 2 secant theta and y as 3 tan theta. Now you give me any value, say theta is equal to 0 degree. What will be x? X is 2 secant 0, which is 2, and y is 0. So you get a point 2, 0. Pick up any value of theta and you will get a point on the hyperbola. Keep on tracing. A square is 16. A square is 16, b square is 9. So this should be 4 secant theta and this should be 3. So the point will be 4, 0. And parametric equations sometimes are easier to deal with. That's why we use them. So equation in the when you are given a point in parametric form, we can also find equation of the tangent. How? What is the equation of tangent? If we take x square upon a square minus y square upon b square equal to 1, and the point is a secant theta, b tan theta, what it means that x1 is given to me as a secant theta and y1 is given to me as b tan theta. So therefore equation of tangent becomes what? X into x1, that means a secant theta divided by a square minus y into b tan theta upon b square equal to 1. So this becomes x secant theta upon a minus y tan theta upon b equal to 1. Is that okay? Let's see. This I've already told you that for every value of theta, the point lies on the hyperbola. And the next slide you will see the equation of the tangent. It is x secant theta upon a minus y tan theta upon b equal to 1. Now on this, a number of questions can be. Oh. If you are given that there is a point on a given hyperbola with parameter pi by 4. Suppose you are given parameter pi by 4 and hyperbola is also given. How will you write the hyperbola? Suppose we take general hyperbola with so a square is 25. This implies a is 5. B square is 64, implies b is 8. So what are the coordinates now? Parametric coordinates. It is 5 secant theta and y is 8 tan theta. This is parametric form. What we want is equation of the tangent for theta is equal to pi by 4. I can directly use this equation. X secant theta upon a minus y tan theta upon b equal to 1. This is equation of tangent. And if we want theta is equal to pi by 4, I can substitute x secant pi by 4 upon a minus y tangent pi by 4 upon b equal to 1. But what is a? In our case, a is 5, b is 8. Let me substitute a as 5 and b as 8. So the equation becomes x. What What is secant pi by 4? Root. So cos pi by 4 is 1 by root 2. So it is root 2 upon 5 minus y upon 8 because tangent pi by 4 is 1. This is the equation I get. You can see it is a linear equation in x and y, and therefore it represents a straight line. It is a tangent. Tangents.
Yes, concept of tangents.
Some student has asked me to explain the concept of a tangent. I told you that whenever you consider a line and a given curve, for example, we are talking of hyperbola. A given line and a hyperbola can meet at 2 points, they can meet at 1 point, or they may not meet at all. As in these three cases. Suppose I am considering one branch of the hyperbola. I draw a line. Suppose I call this line L. This is meeting the hyperbola at 2 points. 1 point is this, 1 point is this. I draw a line here. This particular line, let me call it L dash, does not intersect with this hyperbola, or I say it does not meet our hyperbola. There may be lines which meet hyperbola in just 1 point. For example, this. So this line, let me call L double dash. This is a tangent to this particular hyperbola at this point. We can have a point here and a line touching it only 1 point. And this is not true only about hyperbola. It is true about any curve. Talking about conic sections, if you take a circle, this is a tangent, this is a tangent, this is a tangent, this is not a tangent because it meets the circle in 2 points. This is not a tangent because it does not meet the circle at all. Anything else? Okay, thank you.